So Sean is going to talk to us about DevOps. And when I asked Sean about how he wanted me to bring him to the stage, he was very humble and said that, there's not much to say about him. He's just an enthusiast and he's passionate about security. So I think he's going to have a lot more than that saying. You're going to have a lot to say about Sean when he leaves us tonight. So Sean, without further ado, I'm going to turn it over to you so you can wow us with your passion for security and DevOps. Take it away.
Thank you. I am just going to share my screen and hopefully you can all see this. All right. Can you see the slides okay? Great.
We can.
Awesome. I'm just going to move that there. Great. Well, firstly, thank you very much for having me. It's a great pleasure and honor being here. Thank you for everyone for taking your time to listen to me waffle on about security. I think this is a really important topic. DevOps is obviously becoming a very big thing. It's been used for a number of years now, and it's increasingly becoming more and more of a thing in organizations. And that's great. And I'll talk about some of the reasons why it's great, but also from a security point of view, there's a lot of potential, but there's also a lot of potential of getting things wrong. So it's about how we can merge the two and come up with DevSecOps and help each other, help different teams, and eventually help the customers and help your organization. So just a quick bit about me. I don't like giving things about myself, but I am quite busy on Twitter. So that's my Twitter handle if you are interested. And I also do quite a bit of streaming now. So I'm trying to share information and just have fun doing a bit of content around streaming and that kind of thing. So you can find me on YouTube on Sean Wright Sec, or I also do it on Twitch, Sean Wright Sec as well. I generally stream every Thursday at 9 p.m. UK time. I think that makes it 4 p.m. Eastern time. Other than that, my background is from development. I first got interested in security when I was in university. We did it was in my final year of university, postgraduate, and there was a network security course, did that, got hooked, the things that we maybe shouldn't have done in the labs, but we had loads of fun, and that's kind of where my passion and desire from security started. Unfortunately, back in those days, there wasn't that much in terms of security, in terms of roles. So I went with what I had with my degree, Bachelor of Science in Computer Science. So I just became a developer, stuck with that numerous years, and then finally managed to get my big break at a company called SecureWorks, where I was a developer and then moved on to security. And I've now been in security for the end of this year will be 10 years. It's amazing how time flies. All right, so when I give these kind of talks around development and different methodologies and then how we introduce security, I think it's important that we take a step back, see where we've come from, see some of the pitfalls of the ways that we used to do things in the past. I'm terribly sorry about that. If my internet's going to die, it dies right in the middle of a talk. Oh, the joys. I was trying to tether to my phone, and unfortunately, I live in the middle of nowhere, so signal's not the best either. So I apologize about that. Hopefully, I won't be cut off again. If I am, you can maybe figure out a way to solve my internet issues as well. So I'll recap on the slide because I don't know whereabouts I got cut off. When I give these talks, I always like taking a step back and seeing where we've come from. I think it's really important because it kind of highlights some of the issues or understanding of some of the issues that we face today, some of the challenges, why some of those were maybe not an issue in the past, but are becoming an issue now, and how we can actually merge the development, the operations, and the security all together to help customers, help the company, and help one another as teams go. So that there is not a bird. It's meant to be a waterfall. I try to add some PowerPoint artistic style to it, and actually realize now that it doesn't look like a waterfall. So that's my bad. But the traditional model that we had was the more traditional waterfall model. And back in the day, when I mean back in the day, we're talking probably 20 years or so ago. And it was a completely different story to what it is today. Like, technology was evolving. It was still going rapid at that point in time, but it wasn't anywhere near the way it is today. If I look back at my university, we had like Java and C and C++, and those are like the cutting edge. You fast forward to today, and there's just so many different new languages, technologies, frameworks. It's actually crazy. Our part of my security job, I wasn't actually doing any of the kind of development side. So I was away from it for maybe a year or two, and I was really shocked at the amount that I missed out on. So not only are we having technologies move faster and faster, but we're also having competitors from our own organization. So our competitors are moving faster and faster, innovating quicker, getting to market quicker, and the customers are expecting that. And that's all good. But I'll cover in a bit why traditional model helps security in a way, and why some of the stuff is a bit of a challenge today. So then obviously moving forward today, Agile. I actually love Agile. I think it's a really great methodology. I'm assuming that everyone on this call thinks as well, given the name. I think it's probably one of the most revolutionary things to date in software development. It's completely changed the way that we approach software development. And as a result, it's made things a lot better for customers, users, and even development teams. We can be a lot more innovative, get things out quicker. There's nothing worse than you slaving away on something weeks and weeks, and then it takes like another 6 months to eventually get out to production, where now we can get it out really quickly with the likes of DevOps. It's this whole continuous process where things are just moving along, being built, get out, being built, get out. It's like a manufacturing line, and this is fantastic from a business point of view. We can get things out a lot quicker. We can get things to customers a lot quicker, and we can become a lot more competitive with our competitors. So we can try to get to market quicker, get new features out quicker. And this is all great from a business perspective. It also means we can get new technologies out and help our product and selling things. But as I mentioned, there are some kind of caveats from a security point of view. So with the more traditional approach, the waterfall model, the way we approach security then is we could take the time to spend on these big monolithic releases. So you're talking releases, maybe a quarterly release or a biannual release, or even a annual release. And yes, it contained lots and lots of different things going out. So each one of those, maybe a container represents a feature there, but it is one big thing that was being shipped. And the point is, you knew when that was coming, so you could plan accordingly. So you could say, right, I'm going to take the security team and we'll spend, I don't know, 2 weeks testing everything, making everything is fine, because we know that's coming in 3 months' time, 4 months' time. So we could plan ahead, we could allocate appropriate resources, and then put safeguards around it. And it was very slow to steer. So when things went out, you could have a lot of checks and balances in place. But as I said, it was very slow. So this made getting new features out incredibly difficult. And ironically, it also hampers security, because if there are flaws, it's going to only come in the next release if it's not severe enough, and that could take some time, and so on and so forth. So very slow to adapt. And if you also look at the way we used to develop, is we used to build everything from the ground up. You used to go to an organization and you'd be questioned why you want to use some other library, why you want to use someone else's code. Companies had their own internal libraries, their own internal frameworks, all of that kind of stuff. And that's the way we used to operate. Build everything in-house. And that just helped, or that again slowed things down, because now you're building things, rebuilding things that are already out there, kind of thing. Now, if we fast forward to today, this is great, because we now have this continuous stream of new features going out to our customers. If you got your Agile and your CI/CD process right, your DevOps process right, you could literally push some code, and then a few hours later, it appears in production. And that's great. Now you've really reduced that time to get things out to customers, get new innovation, get new features, get new technology to customers. And that helps you stay ahead of your competitors. And also helps your customers stay with you and excited with your product. But from a security point of view, now we have a problem. We can't just go, okay, well, we're now going to spend the next 2 weeks doing a security test, because that's what we'll be doing 24/7, because we have these constant streams. So now we have to adapt. We have to change the way that we approach things. We can't just do that big, massive security test at the end of it. We have to make sure that we're doing the security test as part of all this effort. And that's kind of where we're going with the DevSecOps, right? But that has a benefit, and I'll cover that in a bit. The other thing is the way we've actually approached developing things has changed. So a couple slides back, I mentioned you would have been questioned why you want to use someone else's code. Now you probably be questioned, well, why aren't you going to use a library for this? Why aren't you going to go look for some open source framework or library that does exactly what you're doing? The amount of open source libraries and usage of those has skyrocketed. If you go look at, there's a company called SonarType. I'm pretty sure that many of you are aware of it. But if you aren't, they run the Maven central repository. So they very much focus in libraries. That's their bread and butter. So they have a product called Nexus, which is a repository manager that supports different things such as Maven, NuGet, even the Linux distribution such as apt and RPM and all that kind of stuff. And every year they produce a report highlighting the usage of open source software. And every year it just grows and grows and grows. It's exploding. And this is great because now we can get things built faster. In the past, we built things from the ground up, build the entire thing in-house. Whereas now I view software development as more gluing different pieces together. So you take a bit here, take a bit there, glue it in such a way that it does what you need to do. And that's great because why reinvent the wheel? And again, that can have some really great security implications. So things like, especially around things like cryptography, where you've probably all heard it before, hopefully have heard it before. Don't roll your own crypto. So rather get a library developed by someone who knows the ins and outs of it. You've got a very strong indication that's going to be secure, and you don't have to worry about it. You can just pull it off the internet, off one of the central repositories, use that, and you know you're going to be generally pretty good rather than trying to do it on your own. Case in point, I've seen a few libraries out there where people try to do it on their own, and they try to be clever. I managed to break every single one of them. So it's really important from a security point of view, using stuff out there. And why spend time on things that you're not really responsible for? in a, well, that's not your day to day. Shouldn't say you're not responsible for security. We all are, but it's not your responsibility to make sure you generate the cryptographic algorithms and all that kind of thing. Another example I want to give is I once got called to assess a web application for a team who had little to no experience in terms of security. It was the most boring pen test I've ever done. Why? Because they use a framework that handle most of the stuff. So things like SQL injection, cross-site scripting, all of those common vulnerabilities that you find in many web apps today were no longer there because that framework dealt with all of those challenges. So again, this is why this whole new approach is helping. These modern frameworks are dealing a lot with the older vulnerabilities. So cross-site scripting, SQL injection, these are old vulnerabilities that have been around since the 90s. And they're still an issue today. But they're going away because the frameworks are dealing with them. And them dealing with them in such a way that makes it a lot easier for development teams. Why should development teams have to spend a whole bunch of effort integrating a whole new library and all of that? Just make it part of it and make it all work seamlessly. So that's where I think it's really, really good. But on the other flip side, there is a downside to all of this. And maybe not the downside is the right word, but there is a risk, maybe is a better term to use. With the explosion of open source, attackers are now leveraging that. We kind of saw that with Log4j. Log4j was probably not as bad as it could have been. And that wasn't a direct attack. That was just a security flaw within a commonly used Java library. It could have been a lot worse, but it was still bad and still being exploited today. The thing that worries me, and I've seen a significant increase in this, is targeted attacks on libraries. And by that, I mean attackers are going after authors of libraries or repositories of libraries, or even presenting a library as being a legitimate library. And then there, they inject that malware. And this is incredibly difficult to detect because of the sheer volume. You have thousands and thousands and thousands of lines of code. I forgot the average number of libraries an application uses, but like it's probably somewhere around 10 or so at least. There's no way you're going to go manually vet that. It's just going to be impossible. So with the explosion of open source, we now have this issue of trusting third party. Now, thankfully, the vast majority, like 99.999% are great. They do an awesome job. So it's about how we start dealing with that. And the industry is starting to look at it. There are some new technologies coming, but it is still something that we need to be very wary of. Yeah. So as I mentioned, like the whole point of DevOps and working through these different methodologies is there's something still missing at the very core of them. And that's security. Often these new technologies like Agile and DevOps and all of that are great. And don't get me wrong, I think they're really, really, really important. I've really highlighted, I'm a big fan of them. But I think we need to start looking at ways of embedding security in it. And one of the things I like doing is when I draw a diagram of a SDLC, you kind of originally insert security, but if you think about it, we shouldn't even be mentioning security. It should just be part of that. Like you don't go, oh, here's a SDLC. We're going to do a unit test there. We're going to do integration tests there and coding there. And it's kind of part of the whole process. It's part of the development of an application. Like, so security should be part of that as well. And you might be asking like, okay, well, this is great, but why should we be concerned about security? Well, there's some benefits of security. Which we'll come on to in a bit. But if we look at why we actually need to start looking at security and embedding it, as I mentioned at the beginning, we have more and more technologies. And as much as I love technology, it makes my job incredibly difficult, because you have all these new technologies be thrown at you. You're like, great, now I got to go learn this technology, and then 2 months someone else is using something new, so now I have to go learn that technology. And as you can see, there's no way a team of 2, 3 people for a smaller company, or even a team of, I don't know, 10 or 15 people for a larger company can keep up with all of this. And we're not going to be experts at it. We kind of forgot what that saying is, master of all trades, that kind of method thinking.
Jack of all trades, master of none.
That's the one, jack of all trades, master of none. That's kind of what we are. We try to be experts at everything, and we don't. We fail. But we try as best as we can. And the more that we can have up front and addressing this, as well as working with those who actually know a lot more about those technologies than we do, the better it's going to be. And also, we want to be embedded so we can help things move along quicker. So by working with development teams, QA teams, DevOps teams, operational teams, those kind of teams, we can work together as a single unit and get things out faster and help drive things, and no longer have security as this roadblock or this no people. And this is becoming more important, as already touched on with the supply chain stuff, is attackers are now becoming more and more advanced. They are cutting onto things a lot quicker. There was some sort of stats around how quickly attackers exploits a vulnerability once it's been released, and it's I think it's measured in hours. So they're really on the ball. They have loads of time. They have loads of effort. They have loads of resources. And we see this time and time again. This company gets breached. This company gets breached. I mean, just this week, there was news about Twilio, and 130 organizations were affected by that. So it's just something that's just going to keep on happening. But if we start doing some of these things, we can make it a lot more difficult for them. I'm not saying we're going to prevent them entirely, but we're going to make it more difficult for them at least. And then once you start looking at security and doing security, it brings some additional benefits. So it could potentially bring in more money. By that, I mean, you can get better sales. It's now becoming, okay, well, we do this, our competitor doesn't do this, so why use them, use us, kind of thing. It can also help in terms of resourcing. So if you start building up and integrating like DevSecOps and that, you can start freeing up people to do other things and get focused on other things. I talked about like modern frameworks and that. So if you start focusing on things like that, you're now starting to free up your development teams to focus on what really matters to the company and what those teams are really hired to do. The company confidence and competitive advantage relates into the money. So increased sales, better customers, more customers, and better opportunities there to get more customers. And then ultimately is better quality. I've yet to discover a really good secure application that is poor quality. The quality and security kind of go hand in hand. So it helps drive quality. I think that's something that's often missed. Obviously not all the time. It's not going to always solve all the quality things, but generally, if you have a secure application, it generally is pretty good from a quality perspective. Because really, there's a lot of things that you do from a quality perspective. If you do those, it's going to help with security. So this is all good, but how do we actually do this? Like, what do we do? Like, what tools and all of this that we can think of when we approach security and application security? When I get asked, how do I implement application security? These are the first three things that I recommend to anyone. And these are tools. And I kind of view these as like the three pillars or three cornerstones or whatever you want to call them, foundational tools, whatever. But if you have these three tools in place, this is going to help you significantly. It's going to give you the most coverage for the least cost, for the least effort. And it's going to be something that you can continually use time and time again. It's going to be something that you can start integrating in your DevOps, your Agile pipelines. So on the right there is your SAST. So it's your static application security tooling. That is a tool that will scan your source code. So it actually looks at the source code and it tries to find security flaws and weaknesses in your source code. Now, there is a bit of a deviation from where that tooling started off to where it's going today. I don't know how far it's going to go this way, but in the past, SaaS-based tools would look at the code and try like work out the logical flow in the code. So for example, if you're looking like cross-site scripting, vulnerability, which is basically injecting HTML on a web page, it would look, okay, well, there's this request parameter that comes in. There's no filtering done on this request parameter that's coming in and then displayed to the page. So this is a potential cross-site scripting vulnerability. It generally works. Some tools are better than others. But where the tooling is starting to go towards, and I don't know if it's going to completely go towards this, is they now looking at known bad practices. So, for example, if you're using a framework, frameworks are a really good example. As I mentioned, many of them by default disable or do HTML encoding, which then helps prevent things like cross-site scripting vulnerabilities. Now, there's an option to disable that. And if someone disables that, that should immediately flag up and go, well, this is a potential for a cross-site scripting vulnerability. So these tools are now looking at knowing, or basically signatures for knowing bad code. So one of the most popular ones out there is SameGrep. And they have all these different signatures that you can then run through your source code and it'll try to identify them. The flip side of this is it's incredibly quicker than your current tools that scan the source code. And there's also potential for less false positives. The next tool is SCA. Now, sometimes this gets confused with SAST. SAST can also be referred to as a source code analyzer, also SCA. But SCA in this context is a software composition analysis tool. This breaks down your application into what components make up that application, primarily what libraries are making up that application. And this is really important because you can't update your libraries or fix them unless you know what's actually being used. So an example of like Log4j, everyone was trying to find out files on the system and that, where in reality, you should be running your source code through SCA. It would spit out, okay, you're using Log4j version X, here, there, and there. There are tools that dynamically scan off the cuff and have the results separately. What I recommend is having a tool that correlates all the results into a single location. The reason for that being is it's a single pane of view into all your components used across all your projects. And that's incredibly important when you have a vulnerable library coming out and you need to quickly identify where that library has been used, if that library has been used and where it's been used in your organization. So some of these tools like OWASP Dependency Track, really, really good tool, free because it's an OWASP tool, and it's excellent tool. I highly recommend you go have a look at it. You can plug in the library and the version, and I'll tell you what projects are using it. So if you're using a vulnerable version and there's no known vulnerability in one of the vulnerability databases yet, so no tooling will report on it, you can quickly look it up, identify where it is, and fix it. They also report on things like licensing issues, as well as the vulnerabilities from the vulnerability database. So a really, really, really powerful tool. And then last is your DAST tool, which is your dynamic application security testing tool. This is used for kind of, think of it like an automated pen testing tool, penetration testing or security testing tool. So you'll have a web application running or API, and it'll try to probe that for known vulnerabilities. So I actually go in and try execute or try be a user via a browser and try inject malicious payloads into different input fields or parameters and that kind of thing. There is a IAST, which I always forget what the I is. Integrated application security testing, I think. But that kind of sits between a SAST and a DAST. So that actually takes the source code with your dynamics application security testing, and it uses that to be a lot more logical about the testing that it's doing. So it ends up with being a lot more accurate results and more thorough results as well. So this is all great. As I mentioned, those three kind of cornerstone tools should form part of your DevSecOps testing, but there are other things that you can have. So you got your static analysis. So this would be both your SAST and your SCA tooling. Threat modeling is really important. So this is part of your designing. Your code reviews. I think the debate's still out on code reviews. I've seen far too many things miss code reviews. The problem I have with code reviews, they're only as good as the person reviewing them. I hold my hands up. I'm terrible at code reviews. I will gladly admit that any day of the week. Some people are really, really, really good at it. Other people like myself are terrible at it. So you're going to get very mixed results. Also, if someone's having a bad day, they might not be paying much attention and miss that one critical line of code. So code reviews do have their place, but I wouldn't rely solely on them. That's why you need all these other tooling, all the other tooling. As I mentioned, you've got the DAST tooling. DAST is really good at kind of automated type checks. It's not going to do a lot of your kind of business logic flaws where there's an error in the way the functionality flows. So think of a checkout scenario where someone could try change the price of something via some weird magic on their end. Generally, the tool is probably not going to detect that. Or if you follow this sequence of steps, you might be able to do something that's not accounted for. So that's where something like penetration testing comes in. You actually have a human doing that. You can't replace a human. It's really important that you have that. And then moving off to the right there, you have more of your GRC, which is your governance, risk, and compliance. It's kind of like all your compliance and your auditing and your, mostly around compliance, how you meet those. So you have your logs and your audits, as well as the monitoring and that kind of thing. Threat intelligence, also really important. So you start feeding that into some of the things that you want to protect your organization and application against. But that's a very simple view. There's loads and loads of tools out there. This was taken from JFrog. So JFrog are another company. They're kind of direct competitors to Sonatype. They do Artifactory. They're actually doing a lot of really good work in this whole supply chain, finding malicious libraries there. So I follow them. They have a lot of good stuff coming out of them. So how do you fix all of this? How do you deal with this? There's a lot to do. Well, the first thing is automation. You have to automate. You're not going to get anywhere without automating this stuff. as I mentioned, like right at the beginning, you have this big monolithic release in the past. It was fine. You could do that manually. Now you have this constant stream. There's no way you're going to keep up. There's no way you're going to be able to test everything. There's no way that you're going to be checking every library, every line of code, all of that kind of stuff. It's just going to be impossible. So this is where the tools come in and are going to really help. They're going to take that burden off that team. So either the development team as well as the security team, and let them focus on the more important things. Let them focus on some of the more manual testing and that kind of thing. And the other thing that I think is really changing the way you approach things, I've certainly seen it, and I've certainly seen the power of this, is the build pipelines. So I'm talking like CI/CD build pipelines here. So I think Jenkins is Jenkins Blue or something like that. GitHub has GitHub Actions, and then GitLab has their own, I think, CI/CD or pipeline or something like that. This is going to really help, because now you can start having the real DevSecOps coming in. This is kind of cool. I think this is probably why I love it so much, because coming from developer that love developing, you know, like developing all this functionality and tooling and that in code. So it makes it interesting, especially for developers, and those are closer to the code. You're now building these things like Docker containers via code. You are now configuring them essentially via code, YAML, that JSON, that kind of thing. But it's still close to code. You're not going off and writing all these boring documents like you used to in the past, where you have all these checks and Excel spreadsheets and all of this. We're now moving to this point where a lot of this tooling is exciting to do. So you're going to have people excited to do it, and we're not having to do all the boring, mundane, archaic stuff that, you know, go write this document that one person read and everyone else didn't read. So this is why I'm really excited about this kind of stuff. I've really seen the power of this and how it can help. And it kind of feeds into this. So on the bottom there, I've tried to indicate like the different parts of a SDLC. Like if you're looking at the application, you've got the developers who will build its code and build it and write tests and that for it. Then they will check that code in, and then eventually that code will get released. And what you have on the left-hand axis there, or the y-axis, is time. And by this, I mean, this is something that we should pay attention to when we're implementing these tools. So if I take an hour to run my scans on a developer system, they're going to go mad. They're going to be so counterproductive, it's going to be crazy. So right on the left there, we need to have something that's very quick, very fast, almost instant results. Once I've checked the code in, it's fine if it maybe takes, I don't know, 20 minutes, 30 minutes to run a scan. Once I've checked the code in, they can come back, check it, make sure it's okay. But if it's going to be like 24 hours, that's probably going to be a problem. And then if we move further on, we have that release build where it's fine maybe if it's going to take, I don't know, 24 hours to generate a build and check it before we can push it into production. Maybe it's not, but you kind of get where I'm going, where we have right on the left, really small time, and right on the right, we can allow a lot bigger time. And this is important when we implementing the different tools, because when we're implementing those different tools, as we start moving left, we're going to become more thorough with those tools, because as we become more thorough and more tooling means the longer time it's going to take to do those things. So some dynamic application security tests will take hours to run. You don't want that happening on the developer's side. You want that happening as like a check before something goes out. And then you have the middle ground where something can take a good few minutes to run, but it's okay. because the developer is not going to go check and then go, okay, well, I need results immediately. They'll probably check it and just check emails on that and then come back to it. I'm hoping. So this is really important because this is getting to the whole point where we're starting to shift security left. So while we in the past used to really focus on doing checks before a release build, we're now trying to get things sooner, right to the developers, right to even the design and planning with threat modeling. And it's important that we do it so there's greater adoption. And that's why the time part of this is really important, as well as making it easy. So one of the most difficult things that we could do is putting something in place that already has a bad reputation, let's face it. Security has not always got the greatest reputation. And now it's just an additional thing to do on top of everything else. So making it easy, making it seamless to use is going to result in better adoption. And one such example I can give of this is in a company I worked at, we were implementing identity provider platform, so single sign-on. Now, we could have gone to the development team to say, here's the server, you connect to it, you do your thing, job done. What we did is create a library for them, and it took them, 2 or 3 lines of code to integrate. That was it, 2 or 3 lines of code. So from that perspective, yes, it was work, but it was a very little bit of work. Like, I don't know how long it took them to write those 2-3 lines of code. I'm not going to say like no work at all, but they'll have to do tests and all that kind of stuff. But the point is, we try to make it as easy as possible for them. And the general adoption was really, really great. So doing things like that, making libraries and that is really important, as well as the tooling. Making sure the tooling is easy to use, easy to understand. Some of the tooling I've seen has been terrible, and the result is just adoption has been terrible. This is another really important one. The snake oil, the marketing, our product is going to solve all your problems. And if you buy our product, it will make you 100% secure and all this stuff. There's actually one vendor, I'm not going to say who, but there's one vendor who is well known in the industry. They are an upcoming name, and the product I thought was really good. I had high hopes for it until I tested it, and it turned out to be not so good. It didn't find some really fundamental flaws, and when I took it to them, their answer wasn't satisfactory. So this is why it's really important to do your homework. Don't buy into the marketing. Do your research, do your evaluations, make sure it's going to fit and work for you. It might be a fantastic product, but it might just not be for you. So this is why it's important to make sure that you review these products, test them out, make sure they're going to be a right fit for your product, your organization, and your teams. Really touched on this. So open source. The libraries, great. This is a really strong way, especially the frameworks, of embedding security right within the code. So they do a lot of the work for you, but not just the libraries. So we're talking about tooling as well. So I already mentioned something like OWASP dependency track. That's free. The only cost is the running cost. So the server that you need to put it on. And there are other tools out there, like loads and loads and loads of tools. Like the amount of tools that are coming out is quite mind-boggling. There's loads and loads of tools coming out, and not just tools. There's also free training, online training. So you've got things like Portswigger Web Academy, Sneak's doing a bunch of free online training. So there's a load of free things out there. And this is really important because sometimes security tooling can be expensive. More so, resourcing can be really expensive. So being able to drive those costs down means you can get more bang for your buck, so to speak, So you can rather focus on the resourcing, which are probably the most expensive part of your security stuff, and leverage open source as much as you can. They'll help drive down costs as well as increase adoption. I don't think many people in management are going to complain with the cost of zero versus a cost of, I don't know, 50 to 100 grand for something. This one is really important for me. We've always had this friction between security teams and development teams. The developer teams are doing off and they're introducing all these vulnerabilities, and then the development teams are like, oh, the security teams are always getting them away. And if you actually think about it, it doesn't make sense. We all work for the same company. We're all trying to achieve the same goal. Why do we conflict with one another? We should be working together, helping one another, drive the same thing, goals, help the organization, help the customers. And thankfully, I think a lot of this is starting to change now. We're seeing teams working a lot closer with one another, a lot more collaboration going on. So this teamwork is really important. There are things that we know about that can help the development teams, but at the same time, the development teams know things that can help the security teams. So it's a yin and yang type thing. Really important. Embedding teamwork means you'll have better cohesion as well as better security culture. And then kind of the last final bit is when you're approaching all of this, so you often get to the starting point and you just look at all of this and it's just like, wow, there's this massive mound of work to do. It seems like a mountain to climb. Where do I start? And if you remember those three tools, that's kind of where I'm going with this, is take small steps, take baby steps, do one thing at a time. Focus on one tool at a time. So in terms of those three tools, get one tool in, get it working, get the teams familiar with it, then move on to the next tool, and then the next tool. Work in iterations. Essentially become like a whole development cycle yourself. And that's that. Any questions?
Wow, Sean, that was a lot of information. I'm sure there are questions. I saw some questions flying in the chat. Does anybody want to start us off?
Sure, I can ask a question. Can you hear me okay?
Yeah.
So shifting security left, which is what you talked about, right? Developers really, doing their own findings is good. But however, you really don't have much visibility. You as a security group don't have much visibility into what got fixed then, right? Like anything post-release, you can produce metric for, right? And therefore show the state of security, if you will, right? Like findings from the tools. But what they found when you shifted security left, what they found pre-release could really be invisible to you.
This is why it's so important to embed security in the tooling. So this is why I'm really excited about things like the pipelines. With that, you can start getting metrics out of those pipelines and then importing them into a tool. So there is a fantastic tool from OWASP called Defect Dojo. This is exactly what I'm trying to do at the moment. Is it takes input from there's loads of tools. But the important thing is it's going to take input from your SAST, your SCAs, your DAST, and it's going to take all these metrics from everywhere and put them in a single location. And with that, you can then start doing reporting on your metrics. So it could be post-production, or it could be pre-release, or even still in development phase. So you get all of these metrics together, and that way your security team has a visibility. You can have your development and engineering team have visibility into that, so they can see how they're performing, the areas that they may need help in, all that kind of thing. I hope that answers your question.
Yeah, okay, great, thanks.
I saw Gaurag had his hand up next, and then Stefan.
Thanks. My question is around if you could share a little bit about the 3 pillars that you talked about, and maybe kind of speak to, I know the time graph and you talked about what was acceptable timeline, but are you seeing more of almost like really left as in a pre-commit kind of checks versus a post-commit? And are there patterns kind of emerging along those lines, or do you anticipate, or are you seeing the leftmost one can be is once the code is committed and sort of, the build or the integration kicks off?
Yeah, sure. So the going left, as far left as you can, realistically, you're not going to get some of your dynamic scanning done on the left because it's just too, well, firstly, you need a running web app. So that's going to be difficult. And it's also time consuming. So you're most probably going to focus more on your things like your SAST, your source code scanning, as well as your SCA, so your component scanning. Now, some of the tools, like Vericode's probably a very good example of this. They have a IDE plugin called Greenlight, and that does really quick checks, but only does it in like very small bite-sized chunks. So if you're looking to scan a application of 50 megs, I think they have a limit of like, I don't know, 2 megs or something. So a developer can't really use that in an IDE for the full application. You can't use that for the full application. Yeah. They can use it very much for the code that they're working on, because I doubt they're going to be working on something more than 2 megs. So that gives them the information as soon as possible. And when you're looking on the left-hand side, you're probably looking for the really low-hanging, what's called low-hanging fruit. So the things that are the most obvious, the things that are the easiest to fix. Ideally, you want to find everything, but you're finding the things that are like going to be the most problem. If an attacker is going to get them, that's going to be the easiest for the attacker. And that's also a combination of the time to scan and the resources. Then as you do a post-commit, then you have the ability to do like the pipeline, so GitHub Actions and that kind of stuff. So you can start having a bit more resource in it. Again, coming back to Vericode, this is why you don't do this on the developer side, because it takes like probably about 20 minutes to do a scan on their pipelines. So you can't expect a developer to do that every time they want to check the code. So that's why you kind of do that post commit. So I guess like once you do a post commit, 20 minutes is not a bad time.
Yeah, makes sense. Thanks.
Stefan, did you want to go? I saw your hand.
Yeah, I did. I had a quick question. Like, I'm not trying to push back on the question, but I was interested in just the question came up like, what do you do when something is found, a problem is found to the left? And so I'm really interested in why, like, because it's just a failure of my imagination. It's not like I'm saying this is wrong, but if someone creates a security hole and that's found by static code analysis or some analyzer, is that worth tracking? Like, what's the criticality of that, right? So in other words, like if it makes it to an environment, an integration environment, that matters. But if I check in code and the static code analyzer tells me you did something wrong, is that a metric that's important to the company? And again, I just don't know, so I'm asking.
That is a very good point. I've seen organizations where they want to solve everything and fix everything, and I'm totally against that. I don't think it's the right thing to do. Shock horror, security person says don't fix everything. Ideally, we should aim to, but realistically, we're not going to. So that's where an organization has what you'd probably call a risk appetite, where they'd say, right, okay, if it's below this threshold, we'll put a ticket or something in it, we'll put on the backlog, and we'll get to it when we get to it. But if it's like most organizations, I'll just send this queue, and we'll just have it. But it's important that you have visibility of it at least, but it may never be fixed. So you kind of have that line in the sand where you say, okay, well, if a developer finds anything above a medium and above on their IDE, fix that. On the pipeline, maybe a high and critical and above, fix that. But that's really going to be a discussion between yourselves and the security team. And that's why it's important both teams come to a consensus, because then both have the buy-in, both understand where that line is. And yeah, and this is kind of also really important in terms of having a proper security triage process where you can go through these things, go through these vulnerabilities, and have an understanding of the priority, as well as when you're going to fix them and if you're even going to fix them. Hope that answers your question.
It sort of does, but I guess let's say that we have a vulnerability. So, I'm total hypothetical, but we have a scrum, right? And so, we're doing 2-week deliveries, and I deliver something in the first week, and I find, it doesn't pass muster. And so it's passed back to me as a developer, like static code analysis or whatever rejected that. Is it sort of industry practice to track the fact that I failed my static code analysis and maybe the other people in the organization didn't? Or, in other words, like it's important to shift left in terms of preventing problems, but is it important to track problems as as far left as they can? Or is there a moment where those problems are actually the metrics really matter?
It's going to differ organization to organization, but certainly you don't want to use it as a finger pointing exercise. I just want to make that absolutely clear. You don't want to go, oh, Jim over there, or Bob or Alice or Joel, they did a terrible job this sprint, naughty them. You want to use these metrics as a kind of pointing to where their problem areas. So maybe a team has issues with one particular area, and that's where the security team can come in and help them and guide them. It should never be used as a stick. So just making that absolutely clear. And that's going to, as I said, it's also going to differ organization to organization. But one important thing is around these metrics is to have a metric, and ideally you want to see how you're tracking. So are you having more vulnerabilities introduced? Are you having less? And those are really good indications of where you need to start focusing on, like as I mentioned, the different areas, but also where the teams need help or additional tooling, or maybe some of your tooling is not working and doing what it's supposed to do. And coming back to the shift left, but it's all part of that, like helping the teams get the right tooling. So it's not just tooling, it's education, awareness, training, all of that kind of thing. So if we've tracking these metrics and we find that teams are suffering in one area, that's where they get the training, that's where they get the help, the guidance. And then hopefully you monitor that and see if that drops off. Hopefully that helps clarify it a bit.
Definitely, thank you.
David, I see your hand up, please.
Sure. Sean, thanks for this presentation, very good. I feel like a couple of years ago I was in an organization where we were doing a lot of things right. We had Sonar Lint for the developers. We had Sonar Cube for CI/CD. We were using Veracode as part of our release build. I'm curious what you might have recommended we tackle next.
So I would recommend a DAST, so your dynamic application security scanner, if you have like APIs or web apps. It's so DAST tools currently are struggling with the newer technologies. They battle a bit with like HTML5 web apps, so your single page web apps. So it's also really important to do your homework there. And APIs is becoming a very big thing. So fuzzing around APIs and all that kind of stuff. So that's probably where I would recommend spending a bit more time. It sounds like you already got right on the left. Having a bit more on the right, on the said shift left and all that, but it sounds like you got the left like well structured, you got the right tools there. So having that little bit more visibility on the right, especially pre-production, where you can automate that is really important. It's that kind of final check before something goes out. They're not going to catch everything, but they'll hopefully catch the things that really matter. Like those, as I mentioned, those lower hanging fruits. It's kind of like an insurance policy in a way.
Could you provide a couple examples of DAS tools that you might recommend looking at?
Sure. So I know OWASP Zap is a free tool that's being used in pipelines itself. So I think there are plugins for things like Jenkins. So that might be having a worth look at. Then commercial tools. So there's Invicti, what used to be called NetSparker. They probably one of the best ones out there. I know I generally don't give vendors, but I'll give an exception to this. They one of the better ones out there. Portswigger also do some. So Portswigger do Bird Suite. Yeah, and there's a few others out there, but those are the ones that I would recommend having a look at.
Great, thanks.
Welcome.
Great. We have some time left for questions. Does anyone else have any other questions for Sean while we have him? Okay. Well, if there's no other questions, I want to thank Sean for taking the time to talk to us tonight. I learned quite a bit, Sean, more than I think I could digest at this moment, but I think you did a great job for us. We super appreciate having you. I know you put up your Twitter handle. We have this as a contact for you too, Sean, at SeanWright.com. Are there any other contacts you want to share with us beside your Twitter and your YouTube? Do you have an email address where we can get to you directly, or is it on your site?
That email address is great there. I also have a blog site, blog.sean-wright.com. And that's got links to all the other things as well, if you're interested. And yeah, feel free to drop me an email, DM on Twitter, whatever. I'm always willing to help out. And thank you once again for having me. And apologies about the internet connectivity issues.